everyone, we're going to minimize our objective function z equals 3x plus 4y subject to these constraints here. And these first two, that just means we're going to be in quadrant 1, and then we also have those two. So if we get started, if you look at quadrant 1, those are your first two constraints. So that just means we're in, for x is greater than 0, we shade to the right, and for y is greater than 0, we shade up. So we also have 2x plus 3y is greater than or equal to 6. So I'm going to use x and y intercepts. When x is 0, I solve for y, and I'm going to get 2. And when y is 0, this goes away, so I'm going to solve for x, and I get 3. So I'm going to plot those 2 points. My y-intercept is 2. My x-intercept is 3. So here we go. Something like that. All right, and the next one we have was x plus y is less than or equal to 8. This one's easier. When x is 0, y is 8. And when y is 0, x is 8. So we're going up to 8. 3, 4, 5, 6, 7, 8. Graph that. All right. Now for this one, it's less than. That means you're going to be shading downward. You're always shading downward or leftward-ish. And for this one, it's greater than. So you're shading upward and rightward. So we're going to be in this area. And if you want to shade in this area, there is your graph. You can do crosshatch if you want. All right, something like that. Anyway, so let's write down our corner points. Our corner points are actually just these, so I don't need to write them down again. These were pretty easy. And so now all we have to do is minimize this, and I'm going to plug in. I wrote my corner points down as the vertex, and I just plug in everything. So we get z equals 3 times 0 plus 4 times 2. That equals 8. Z equals 3 times 3 plus 4 times 0. That equals 9. And z equals 3 times 0 plus 4 times 8, which equals 32. And z equals 3 times 8 plus 4 times 0. That equals 24. So we want our our minimum. Our minimum occurs at 8, equals 8, at 0, 2. And that's all. Thank you. Have a nice day. Bye-bye.